Hey guys, welcome back to a new video, and in this video we are diving into flow operators, powerful tool that helps you to manipulate and transform your data in reactive programming style. Whether you are transforming, filtering or combining your data, flow operator provide a flexible and concise way to handle your asynchronous events. We'll break down the most commonly used operators, show you the practical examples and explain how they can make your code more clean and more efficient. So let's get started and unlock the full potential of Kotlin flows. So first go to the description box where you can find my GitHub repository link. Download the project and open up into your Android Studio. So basically I gave you the initial setup of this project. So first we will begin with transform operators. So open up this package. Here we are having flat map, map and transform. So we will begin with map file. So here I'm having source flow. So I'm gonna perform some transformation into this source flow. So for that we are using map function. So for basic transformation you can use map operator into your flow. So I'm gonna simply multiply these emitted values with 2 and after that I'm gonna simply collect it. So print ln and collect the values. Now when you execute this main function, so here you can see now we are getting 2 4 6 8 10 12, basically the multiple of 2's. So if you want to perform very simple operation, then you can use map transform operator function. Next we are having transform file. So in this file we're gonna perform some complex transformation. So suppose it is your requirement to perform complex transformation. On that case you can use transform operator. So on the top we are having user action sealed class that has 3 different subclasses: click, swipe and long press, and based on that we are having source flow. This source flow will emit user action click, swipe, long press, click, swipe. I'm gonna use my source flow and here we are having transform and we are receiving the user action. So when our user action, let me use this suggestion. So here you can see we are having user action click, long press and swipe. So in the case of click, I'm gonna emit something different. So for click we are having click and user action has x and y coordinates. So I'm gonna use its x coordinates. Similarly user action y coordinates. Okay. So for the long press we don't have any parameters. I mean we don't have any member variable for this class. Basically it's not a class, it's a data object. So due to that reason we don't have any member variables. So for long press I'm gonna use here long press. Okay. Similarly for the swipe I'm gonna use emit and call this swipe. This time I'm having length. So let's see the length, user action length. Okay. And lastly, once you perform the transformation you can simply use collect latest and collect the emitted value. Now here I'm gonna use print ln, print the values, run your main function. So basically in the source flow we are receiving user actions. Now when we perform the transformation it will become strings and these are the values of our strings. We need to go into our flat map file and here we are going to discuss very important 3 operator functions, which is flat map concat, flat map merge and flat map latest. So let's see one by one. So first I'm gonna begin with flat map concat, but before that you can see over here we are having user id flows. Eventually it will emit values 1 2 3 and based on that we are having fetch order. So basically when you use user id it will go and fetch some order. So it's a kind of mock-up network call. So let's use flat map concat, wall concat, and I'm gonna use my user id flows flat map concat. Okay, now it will give me one by one my emptied values, which is 1 2 3. So based on that I'm gonna use my fetch orders and pass my user id. Okay, now in the main function I'm gonna use my concat and collect the latest emission, print ln, print the values. Okay, so once you execute main function, for the user 1 we are receiving both order, for the user 2 we are receiving both order, for the user 3 we are receiving both the order. So basically if you want to maintain the sequence of your execution, then on that scenario you can use flat map concat. Okay, next we are having flat map merge. So for that I'm going to create a variable naming merge, user id flow flat map merge, fetch orders, pass my user id one by one. Now let's collect the merge, collect latest, print ln, simply print the values. So before this value I'm gonna add few things, which is merge, in order to make a differentiator. So now when you execute it, so here you can see in the merge case we are receiving user 1 order 1, user 2 order 1, user 1 order 2. So basically here we don't see any kind of sequence because flat map merge will execute your flows concurrently. It doesn't care about your sequence, but in flat map concat it cares about your sequence. Here in flat map merge, we don't have any sequence. It's a kind of gibberish. So let's see the execution. You will get a complete idea what goes under the hood. So here we are having fetch order, we are having user ID flows. So first our user ID flow will emit 1. Okay, so for the 1 we go to the fetch order, emit the order 1 for the user 1. Okay, after that it will take near about 100 millisecond delay, but before that our user ID emits this second value. So once it emits this second value, we go to the fetch order and emit the first order for the second user ID. And due to that reason, here you can see we are receiving first the order 1 for the user 1, then we are receiving user 2 order 1 because of this delay. So I think you got my point. What I am trying to say over here is your flow will be executed concurrently with the help of flat map merge. Alright, so now we are gonna look the third one, which is the latest. So user ID flow flat map latest, fetch the order, pass your user ID. So in the bottom I'm gonna collect the flow. So latest, collect as latest, print ln, and I'm gonna add prefix naming latest, and after that I'm gonna print my values. So now it's time to execute it. So here you can see in the latest one, our user 1 receive the order 1, our user 2 receive the order 1, and our user 3 will eventually receive the both order. Well, what's going on under the hood? So in the flat map latest, once it will receive some new value from other flows, it will eventually cancel up the previous flow. So let's see the execution, you will get a complete idea. So for the user ID flow, we are emptying value 1. Okay, so for the first user ID, we go to the fetch order, emit the first order for this user 1. Now it will take 100 millisecond delay, but for our user ID flow we only have delay of 50 millisecond. That means our user 1 flow is not completed. Before that we emit this second user ID, and due to that reason it will go to the fetch order and fetch the first order for the user ID 2. But for the user ID 1 we haven't completed the flow, and when you are using flat map latest, it eventually cancel the previous flow. So in this case for the user 1, because we have not completed the user 1 flow, before that we fetch the order for user 2. So our flat map latest which eventually cancel the flow for user 1, and due to that reason when you open up the results, you can see over here for the user 1 we only receive the order 1, for the user 2 it is the same case, but for the user 3 it is not the case, because after user 3 we don't have any other users. Here we are not able to receive the order 2 for user 1 and user 2. So long story short, flat map latest will only take care of the latest value and it will simply retard the previous flow. So we are done with the flat map things, and these are things that we can use to transform our flows. Let's begin with combinating operators. So basically we are having few operators that we can use to merge one or more flow together. So for that we are having here two files, zip combine. So let's begin with zip combine. So here we are having two different flow, number source flow, letter source flow. So let's combine these two. So first I'm gonna use my number source flow. So I will begin with zip operator function. I'm gonna use my letter source flow. Open up the pair of parentheses. So first it will give me number and second it give me letter. And after that I'm gonna simply create a string and pass my number and letter together and collect the latest emission, print the value 1 by 1. Okay, so execute it. So you can see the result. We are receiving 1A, 2B, 3C. Let's see the execution, what's going under the hood. So on the top, if you see, we are having number source flow and we are having letter source flow. So for the first emission, our number source flow will emit 1 and letter source will emit A, and due to that reason here we are having 1A. But for the second emission, if you look out the flows, so our number source flow is having delay 300 and our letter source flow will having delay of 200. That means our letter source flow will emit values faster. So it will emit B before our number source emitting 2. So once it will emit B, it go to the zip, and zip will eventually wait until and unless it will receive new value from number source flow. So basically, long story short, a zip operator function will eventually wait for flow to emit new value, and then only it will combine these two values and present it to you, or you can say emit it. And due to that reason, here we are having 1A, then we are having 2B, then we are having 3C. But in a case of combine, so let's combine. So here I'm gonna pass my number source flow and the letter source flow. So we are having here number and the letter. Okay, so let's combine these two. So first we are having our number and then we are having our letter. Collect the latest emission, print it. And on the top of this combine, I'm gonna use println in order to make suppression. Okay, so now execute it. Here you can see this is the result for our zip and this is the result for our combine. So zip transformation function will wait for the flows to emit its value and then only it will connect those two values and emit it. But in a case of combine, it is not the case. Here you can see on the top we are having two things, number source flow and letter source flow. So for the first time our number source flow will emit 1 and similarly our letter source flow will emit A, and due to this we are having 1A. Now for the second emission we are having 1B. So see, 1B is coming because our letter source flow will emit values faster, but our number source flow will take little more time, and due to that reason letter source will emit B value before number source flow, and due to this in the combine we are having previously value 1 for the numbers. So it will simply grab the previous value of the number source flow and grab the latest value which is coming from our letter source flow and add it and simply emit it, and due to this we are having 1B. But in a case of zip will eventually wait to number source flow to emit new value, and due to this we are having 2B in case of zip. But in case of combine we are not having this case, we are having 1A, 1B, 2B, 2C. I think you got my point. What is the main difference between these two? I told you, when you want to perform your operation parallelly, you can go with zip, otherwise you can choose combine. It's totally up to you. Next, go to your merge. So in this file we are having two different sources of flow, source flow A, source flow B. So let's merge it, and it's very easy. So we are having a merge function, pass your source flow A and source flow B and simply collect the emissions. So println, pass your values, execute it. So you can see here we are having flow A emission 1. So if you see over here in the source flow A we are having flow A emission 1. So here we are having flow A emission 1. Now after that we are just emitting the source flow B value which is flow B emission 1. So here we are having flow B emission 1. After that if you looking out the delay, so source flow A will have a little more delay, and due to this reason it will not emit the next value, but before that our source flow B will emit flow B emission 2, and due to this we are having flow B emission 2 over here, and after that we are having flow A emission 2. Okay, so by using merge you can simply merge to flow. Now let's see what is the advantage of using flatten merge. So suppose you are having here flow which actually have flow of flows, basically source flow A, then we are having source flow B. Now in this scenario you can use flatten merge. So I'm gonna use flow flatten merge and simply collect the emissions, print the values, and before this value I'm gonna add flatten, execute it. So there will be no difference between the emissions, but the thing is this flatten merge is used when you are having flow of flows like this case. So now we're gonna talk about how you can convert your flow into state flow or shared. So for this open up this package state, and within this we are having state operators. So in this we are having a very basic source flow that will emit values from 1 to 5. Okay, now I'm gonna convert this source flow into state flows and shared flow. So for that here we are having variable naming state flow. I'm gonna use my source flow. We are having state in function, and here the requirement is coroutine scope. So I'm gonna create a scope which is coroutine scope dispatcher.io and pass my scope. So it will eventually become state flow. You can see over here. Similarly, if you want to create shared flow, you can use your source flow. Then we are having share in, pass your scope. Next thing is when you want to start the sharing of this flow. So I'm gonna use here started, sharing started eagerly. And also if you want to pass the reply cache, you can pass the reply cache, but for the timing I'm gonna simply pass 0. Now your source flow will eventually become shared flow. Okay, so by using these two operator function you can easily convert your flow into state flow and shared flow respectively. So in flow operator function we are having a lot of operator function which eventually used to error handling. So let's see what are the functions we are get. So for that open up this error handling. Here we are having retry on each cache. Simply open it up. So in this we are having network request function. Mock up the network request call. So for the first time it will emit attempting network request. After that it will provide some delay of 1 second. Then it will check if our match.random is less than 0.9. It will eventually throw an exception. And just after that if it is not the case, then we got the message which is network request succeeded. So first I'm gonna use my network request. We are having on each. So on each will trigger every time when you emit something from this network request. So I'm gonna use println here, call this on each, and simply print out the values. Next we are having catch. So suppose if you throw any exception from this network request, it simply execute this catch block. So in this catch block I'm gonna use println catch, and also I want to show the message it dot message, and this catch will eventually provide you the exception that we throw from here. Lastly I'm gonna simply collect the latest emission and simply use println. Now execute it. Here you can see first we are attempting network request, and due to this we are coming to this block, and the message that we are receiving is this one, and also it will goes to the collect latest, and after that we go to this particular section which eventually throw an exception, and due to this we go into this catch block, and because of that we are having catch network request fail. I mean the message that we sent from here is eventually appearing on this place. Alright, so now if you want to retry this flow execution, you can do it very easily with the help of a retry operator function, and I want to retry this function for the one time, I mean the flow for the one time. And now here you can see for the first time of our flow execution we encounter exception. I want to retry this flow execution one more time, and due to this it will simply execute our flow for the second time, and after that once it get exception from the second time, then here you can see now we eventually landing up into the catch block and having message network request fail. So basically if you want to retry your flow execution, you can use retry operator function, and also here you can pass the predicate based on some certain condition. You can retry your flow execution, and if you pass this thing true, that means it will execute your block again and again for eternity, and if you simply pass false, that means it will never retry a single time your flow execution. Alright, so that's it for the retry. So we are pretty much done with retry, on each and catch block. Now we're gonna see some filtering operator function that we are having in the flow. So for that first we're gonna begin with take drop file. Here you can see we are having source flow which will emit value from 1 to 10. So now I want all the even numbers from this source flow. So for that I'm using source flow filter and simply write the logic which is it modulo 2 is equals to 0. So this will eventually give me all the even numbers. Collect latest, println. So here we are having even, pass your values, execute it. So you can see all the things are even. Now we have one more operator function which is just reverse of this. So I'm gonna simply copy this thing, paste it over here. We are having filter not, okay, and I'm gonna call this filter not, and after that I'm gonna print my value. So you can see this time we are having all the odd numbers. Now we are having take. So source flow take. So basically if you are passing here count 3, that means it will only take the first 3 emission from this source flow. Now I'm gonna use here collect latest, print out the naming take, then we are having our value. Once you execute it, you can see it will only collect the latest 3 value, I mean the starting 3 values, okay. And one more thing, we are having source flow take while. So basically if you want to take something based on some condition, you can use take while. So I will take element if it is less than 8, collect latest, print ln. So in this case I write a condition, if our value is less than 8 then only you can collect, and here it is. So similarly we are having one more thing which is drop, pass the count. So let's say I wanna drop 3, print the values, drop, then the actual value, and execute it. Okay, so you can see once I pass the count 3, that means it will eventually drop the first 3 emissions, and due to this here we are having 4, 5, 6, 7, 8, 9, 10. And similarly for the drop we are having drop while. Here drop while and pass the condition. So when our it is less than 5, copy this drop while, simply paste it and execute this main function. Okay, so here you can see, look out the condition. So it says if it is less than 5 then you can drop 1, 2, 3, 4 you can drop, and after that you can collect. So it will collect 5, 6, 7, 8, 9, 10. So these are things we are having for take and drop, and also for the filter we are having filter and filter not. Alright, so now we're gonna see distinct until change operator function. So in this file we are having source flow. So this is actually used when you want to remove the duplicate value from your flows. So source flow distinct until change, then I'm gonna simply collect the latest emission, print ln, pass your value, execute it. So you can see 1, 2, 3, 4, 5, but in the emission we are emitting 1, 1, 2, 2, 3, 3, 4, 4 and 5, but here we are having only the unique one. That means if you want to remove the duplicate values, you can use distinct until change. Next we are having debounce. So first let's try to understand the requirement of debounce. I mean what are the cases where we use debounce. So suppose your application have a search query where user can search something. Now if user type anything, you eventually hit the backend API, and it is not a good approach. So in order to minimize our backend API call, what we did, we simply wait some certain period of time, and after that we are gonna hit our backend API. So in order to producing that throttle, we use debounce. So let's see how we can do it. So we are having search query flow debounce. Let's say 200 milliseconds is my time, and I'm gonna collect the latest emission. Simply print the values. Now here we are having 200 millisecond time. So once user types something and wait for this amount of time, then only we're gonna hit our backend API. So execute it. We are collecting the KOT, we are collecting the Kotlin flow, but we are not collecting this K, KO and Kotlin, because once I type K, I will wait near about 100 millisecond, and this 100 millisecond is less than 200 millisecond, and due to that reason we are not going to hit our backend API. We wait. After that user type KO, and the delay is 100 millisecond, which is less than 200 millisecond, and due to that reason I'm not going to hit my backend API. And when user type KOT, it will wait near about 500 millisecond, and 500 millisecond is greater than 200 millisecond, and due to that reason I'm gonna hit my backend API. And after that it will type Kotlin and wait 100 millisecond. So 100 millisecond is less than our throttle time, so we're not gonna fetch our backend API data. And after that it will simply type Kotlin flow and wait for eternity. So wait for eternity, that means we are having a very huge time duration, and due to this eventually we're gonna hit our backend API with Kotlin flow. So this is a scenario where you can use a debounce. Alright, so that's it for this video. I hope you like this video. In this video we saw how to use flow operators, and believe me, these operators are very important for you if you are using these flows in your project. So yeah, if you like this video, subscribe my channel and also write comments if you are having any doubts regarding these operators. Till that, goodbye. We will meet in our next video where we will discuss something new about Android.